In this video, we're going to be looking at function notation. And we're going to take a quick glance at what we already know when it comes to equations. So we have seen equations written where you have y equals 2x plus 6. We've seen equations like these. And in these equations, our x represents what we plug into the equation. It's our input. It's what we're putting in. And then once we've simplified that, whatever we're left over with represents our output, which is our y value. Now we're going to write the same thing, but for our output, we're going to write f of x. And then we'll put everything else the same, equals 2x plus 6. Our x still represents our input. It represents what we're plugging into the equation. However, instead of writing y to represent our output, we're going to write f of x. F of x is a new way to write y or to name our output. To say this new notation, we say f of x. The parentheses we use for the parentheses, we say of. So f of x equals 2x plus 6. Let's go ahead and look at some different representations of notation form. Right, the first one is a graph. So you can see here that I have f of x equals negative x plus 3. And I have the associated graph. Another form is your input and output table, except instead of using x and y, you'll use x and f of x. And then lastly, just the notation itself. So f of x equals negative x plus 3. All of these are different representations of the same function, and now using function notation instead of the standard notation of x and y. Okay, but how are we going to use this to solve things, Ms. Hughes? Well, let's look at that now. We're going to look at how to use function notation to evaluate functions, right? So let's go ahead and look at our first example. We're going to evaluate f of x when it is equal to negative 4x plus 7. And we're going to evaluate it for two different scenarios. We're going to evaluate it for when x is equal to 2 and for when x is equal to negative 2. So we're going to start with our first one, x equals 2, and we're going to rewrite our equation. F of x equals negative 4x plus 7. But everywhere there was an x, I'm now writing the number 2 because I'm plugging 2 in, not just x. And I'll begin to evaluate that. Negative 4 times 2 is 8. Negative 8. Negative 8 plus 7 is negative 1. So when I plug in 2, f of 2 ends up equaling negative 1. What happens when I plug in negative 2? Well, I'm going to do the same thing. Instead of plugging in positive 2, I'm going to plug in negative 2. So f of negative 2 equals negative 4 times negative 2 plus 7. And I'll begin evaluating that. Notice my f of, I just keep carrying it straight down. So I write it over and over and over. It's not actually doing anything. It's just reminding the reader why we were there in the first place. So again, I'm going to write f of negative 2 equals negative 4 times negative 2 is positive 8 plus 7. All I have left to do is add 8 and 7. Again, I'm just carrying that f of negative 2 down. And 8 plus 7 is 15. Okay, so I can conclude that when x is equal to 2, f of x is equal to negative 1. When x is equal to negative 2, f of x, the outcome, is equal to 15. Instead of saying x and y, I say x and f of x. Knowing the difference between this input and output is important because sometimes you're going to be given the output. So before we were given our x and we plugged it in, now they're saying find out what x equals when f of x, that output value, is equal to negative 5. Okay, so now what I'm going to do is I'm going to demonstrate this, I'm going to start by rewriting the entire function. So I'm going to rewrite f of x is equal to negative 4x plus 7. That's exactly as it was before. I need to replace all of f of x with negative 5. So I'm going to erase it at this time. All right, and I'm going to replace that f of x with the number negative 5. And now what I have is a two-step equation. Oh, I don't like pink. Blends in with the top. We'll go with green. Oh, real wild times over here. I'm going to subtract 7 from both sides of the equation. That's the constant. When I do that, I end up with negative 12 equals negative 4x. I'll divide by negative 4 on both sides, my coefficient, and that leaves me with x equals 3. So when my output is negative 5, the input x will end up being 3.